This lesson video covers perfect squares and simplifying radicals. These are a couple of skills that we're going to need before we move into Pythagorean theorem and then on to basic trigonometry. So what is a perfect square? A perfect square is product of two identical integers. And by product, we mean multiply. On the left, I have some squares, some perfect squares. I have a 2 by 2 and a 3 by 3 and a 4 by 4 and a 5 by 5 and a 6 by 6. And when I multiply those out, 2 and 2 is 4, 3 times 3 is 9, 4 times 4 is 16. And I know most of us are quite familiar with this, but we always have to backtrack a little bit when we talk about something new. So I can rewrite each of these: 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. And my perfect squares, I'm going to highlight those. My perfect squares are 4, the 9, 16, the 25, and the 36. Now in my grid here, my multiplication grid, which we're all familiar with because we've done these in class several times. And for the sake of time here, I'm just going to fill in perfect squares. Nine times 9, 11 times 11, 12 times 12. And these we should have them memorized. Now what I'd like for you to do when you fill yours in, so I want you to go through and highlight just as I'm about to do here. So you can visually see what's going on. And I'd like for you to use some color. And I'll choose gray. I'll do a couple more. But you get the idea of how these represent, how the highlighting is showing perfect squares. Okay, I'll let you finish that up. On to radicals and parts of a radical. So parts of a radical, we're going to use our word bank. And first thing we're going to highlight here is the radical symbol. So that's kind of looks like division. And it kind of is division. What's different about it is that when we talk about a radical versus dividing, we're looking for identical values that make up the number that's underneath the radical, which is called the radicand. So I've labeled the radical symbol, the radicand, the index. The index is this space right here. This space right here. And when there is nothing in that space, it's assumed that we're looking for the square root of the radicand. The square root of the radicand. In other words, we're looking for two identical values that, when multiplied together, will give us the radicand. Now, sometimes that index is a different number. Maybe it's 3. In that case, we're looking for a cube root, or we're looking for 3 identical values that, when multiplied together, will give us the radicand. Or sometimes we have a 4th root, or a 5th root, or sometimes just an n root. But the point is that that's our index. That is where we determine what kind of root we're looking for. And if there's nothing there, then we're looking for a square root. Now, the only kind of square root that we're concerned about right now is the principal square root. Now, the principal square root is always going to be the positive square root. That's what I mean by principal square root, is the positive square root. Now, square roots can be negative. Negative 10 times negative 10 is positive 100. So when we're asked to find a square root, it's kind of important to know, are we looking for all the roots? In other words, are we looking for the negative and the positive roots? But most of the time, we're just concerned about the principal square root of a number, particularly with Pythagorean theorem, which is coming up. We're only concerned about the positive square root. Okay, so now we're ready to talk about simplifying radicals. So when we're simplifying radicals, it's a lot like simplifying fractions. When you're asked to simplify a fraction, you're not looking for the decimal value. You're not punching it into your calculator to find a decimal value. You're just simplifying it down to its lowest terms. And when we do that for radicals, when we simplify it down to its lowest terms, again, we're not concerned about the decimal value that your calculator tells you. So we're going to focus first on this middle box here. Here we go. We're going to focus on that first. And inside of this box, we have some square roots that we're looking at. And each one of these square roots happens to be a perfect square. So the square root of 1 is 1. Or 1 times 1 is, of course, 1. 2 times 2 gives us 4, so 4 is a perfect square. And the square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. And I think you see where we're going with this. Square root of 36 is 6. Square root of 49 is 7. And we have 8, 9, 10, 11, 12, Square root of 169, that one pops up frequently. Square root of 225 is 15, that pops up frequently. Square root of 256, that's less frequent. One through 12 you should have memorized, and 15 pops up quite a bit. And square root of 400, that's easy, it's 20. So those are our first 20 perfect squares. Okay, so now that we have our perfect squares filled in from 1 to 20, of course, when we're asked to simplify a radical, those aren't always going to be a perfect square. So what do we do? Well, just like simplifying a fraction, we're not going to punch it into our calculator. We're just going to reduce it to its lowest term. So in the example here, we have square root of 160. And the 160 is broken down into 16 times 10 underneath that radical symbol. And why 16? Because 16 is the greatest perfect square factor of 160. The greatest perfect square factor. So just like if you were simplifying fractions, you're looking for the greatest common factor, the GCF. And you're going to pull that out of your fraction in order to simplify your fraction. Same thing's true here with simplifying radicals, only we're looking for the greatest perfect square. So our greatest perfect square of 160 is 16. And 16 times 10 is 160. And then those two values are rewritten right here. So the square root of 16 times the square root of 10. And of course, the square root of 16, because it's a perfect square, comes out to 4. And then I'm left with the square root of 10. And there's nothing more that you can do with that square root of 10, so it simply just stays as it is, square root of 10. We're done. We have simplified it as far as we can take it. And that's how we do all of these example problems here. So some of these are going to take some trial and error, but we will get through it. So square root of 44, this first one here, I'm going to rewrite that as a square root of 4 times 11. And I chose 4 and 11 because, well, those are the only factors of, not the only factors, but close to it. 44 doesn't have a lot of factors, but I know that 4 is a perfect square. And the square root of 4 is 2. And then I'm left with 11, which doesn't reduce any further. But yeah, that one was easy because 44 doesn't have too many factors. 32 has a few more factors, so it might take some thought, some planning, and some trial and error. But I know that 16 times 2 is equal to 32, and 16 is a perfect square, and the square root of 16 is 4, and then there's my answer, because there's nothing more that I can do with that square root of 2. 80 is 16 times 5. Now I can check that part with a calculator if I want to. Or I'll just multiply it over here on the side. Do my scratch work over there. So again, the square root of 16 is 4, and then I just have 5 left over. And I'm going to minimize my work here because sometimes I write big. Okay. 3 times the square root of 45. So my 3 is on the outside of my radical. And that's okay. 45 breaks down into 9 times 5. The square root of 9 is 3. All right, I'm not going to take any shortcuts here. So I have 3 times the square root of 9 times the square root of 5. Square root of square root of 9 is 3. And I cannot reduce the square root of 5. So 3 times 3 is 9 times square root of 5. And there we go. 162. Oh, goodness. Okay, so you have a big number like this. Try dividing it by a small number first, like 2 or 3. So 160, and see if you get a perfect square out of that. So I'm going to take my 162, and I'm going to divide that by 2. What do I get? 81. 81 is a perfect square. So I'm going to rewrite this as 81 times 2. And square root of 81 is 9. And square root of 2 just stays right there under the radical. 121. Square root of 121 is, of course, 11, because that is a perfect square. So there's my answer. Don't forget about the 5. The 5 was on the outside of the radical, so it is multiplied by the value that is inside the radical. There we go. Same thing over here. I've got 2 times everything inside the radical. Square root of 112. So 112, I'll divide that by 2. What do I get? 56. 56 is not a perfect square. So now I'm going to try 3, 4. 3 is not going to work. 3 won't work because 112 is not divisible by 3. But let's try 4. 4 will go into there, into 11 twice, with a remainder of 3, and we'll go into 8 times. Well, that is not a perfect square either. But I feel like I'm getting closer, maybe, because 28. So 28 times 4 is 112. So, sometimes you have to do some trial and error. Now, 4 is a perfect square. However, 28 can also be written as 4 times 7, which also gives me another perfect square of 4. Now look here. I've got a 4 and a 4 and a 7. 4 times 4, of course, is 16. So I can rewrite this as 16 times 7. Now, you can check it on a calculator. But, I did all this so you can see that sometimes it does take some trial and error to find out what your greatest perfect square would be. Now I'm going to check this real quick. That's multiplying. So yes, 16 times 7 is 112. Square root of 16 is 4. And then I'm left with square root of 7. So now I have 2, which was on the outside of my radical, times 4, which is the square root of 16, times the square root of 7. So that's going to be 8 times the square root of 7. To minimize that. Okay. And finally, I have negative 4 on the outside of my radical and the square root of 500, which that should be pretty easy, right? 5 times 100. I know that 100 is a perfect square. So now I have negative 4. The square root of 100 is 10. And then square root of 5, which I cannot do anything about. So negative 4 times 10 is negative 40 times the square root of 5. There it is, simplified. So this one works out to be negative 40 times the square root of 5. Ta-da!